Hello everyone, we are Group 1 from Civil Engineering Department and we're going to talk about the earthquake in civil engineering. So for the introduction, I'm going to tell you about the definition of the earthquake and what causes earthquake to happen. An earthquake is a shaking of the surface of the earth resulting from a sudden release of energy in the earth's lithosphere that creates seismic waves. So what is seismic waves? Seismic waves are waves of energy that travel through the Earth's layers and are a result of the earthquake. And what causes earthquake to happen? In general, earthquake caused by a sudden slip on a fault, and fault is the surface where they slip. The Earth has four major layers: the inner core, outer core, mantle, and crust. The crust and the top of the mantle make up of a thin skin on the surface of our planet. But this skin is not only just one piece, but it's made up of many pieces like a puzzle, and they keep slowly moving around. And we call these puzzle pieces as the tectonic plates. The edges of the plates are called the plate boundaries, and the plate boundaries are made up of many faults. Since the edges of the plates are rough, they get stuck while the rest of the plate keeps moving. And finally, when the plate has moved far enough, the edges unstick on one of the faults and there is an earthquake.
Hi everyone, I'm Kirana from Group 1 and today I would like to discuss about potential earthquake in Indonesia. Earthquakes are probably the biggest threat in terms of natural disasters in Indonesia, as they come suddenly and can strike in populous areas such as the bigger cities. Being located on the Pacific Ring of Fire, Indonesia has to cope with the constant risk of earthquakes. Earthquakes form a constant threat in Indonesia due to the meeting of major tectonic plates and volcanic activity in the region. On several occasions during the past 20 years, Indonesia has made global headlines due to devastating natural disasters that resulted in the deaths of hundreds and thousands of human and animal lives, plus having a destructive effect on the land area, including infrastructure, and thus resulting in economic costs. On average, Indonesia experiences about one earthquake per year, with a magnitude of 6 or higher that cause casualties as well as damage to the infrastructure or environment. As you can see, below is a selected list with recent earthquakes that caused severe damage and at least 20 fatalities. Okay, so this is an earthquake hazard map in Indonesia. As you can see, Nanggroe Aceh Darussalam is classified as a high potential area. West Sumatra and Papua are also considered high-risk areas. Riau Islands is classified as a low potential area, and the rest of the area is categorized as medium. So, thank you.
Okay, I will explain some earthquake cases in Indonesia. In this occasion, I will explain about earthquake in Bantul, Yogyakarta, and Bandar Lampung. Earthquake in Bandar Lampung. The west coast of Lampung is an area that has a high potential for disaster, both earthquake or tsunamis. Larger earthquakes have occurred in 1933 and 1994. Even the Richter scale were not more than 7.7 Richter scale, but the epicenter of the earthquake were from interplate collision zone in waters West Lampung and along Patahan Active, Sumatra. And the last earthquake in Bandar Lampung was on 16 June 2006. Earthquake in Bantul, Yogyakarta. The largest earthquake in Bantul, Yogyakarta was on 27 May 2006. The earthquake was devastating due to the shift of the opaque plate, which caused 5.9 Richter scale for 52 seconds, with the epicenter at a depth of less than 10 kilometers just below Bantul. Even though the earthquake didn't last long, but the impact of the earthquake was more than 5,000 people died, almost 40,000 people were injured, and more than 200,000 houses were damaged. Many things happen because earthquake, like crack and collapse building, a reduction of structural ability withstanding load, and many more. Why can it happen? It can be happen for many reasons, like not detailed building, incorrect looping details, mismanagement of building, and improper selection of building material. Here's the illustration: improper selection of building materials and mismanagement of building.
The ground also has specific resonant frequency. Hard bedrock has higher frequencies than softer sediments. If the period of ground motion matches the natural resonance of a building, it will undergo the largest oscillations possible and suffer the greatest damage. Small buildings of 1 or 2 stories resonate naturally at much less than 1 second periods, as 1 second period will affect buildings of about 10 stories. For example, a 30-story building resonates at a period of 3 seconds, and a 50-story building resonates at a period of 5 seconds. During the 1985 Mexico City earthquake, the ground beneath the city resonated with a 2-second period for over a minute. Thus, medium-height buildings with similar natural periods suffered the most damage, while short, old, weak stone buildings and skyscrapers were relatively undamaged. That proved to be what is called a resonance disaster, which is how engineers describe the destruction of a building by seismic vibrations at a system's resonant frequency. Key point here is that small buildings on hard rock and large buildings on soft sediments may suffer more damage and ground motion effects from an earthquake than small buildings on soft sediments and large buildings on hard rock.
Weak materials can fail. Shear forces can bend or break unbraced walls and bridges. Untethered houses can slide off their foundations, and heavy roofs can collapse. Earthquakes release seismic wave energy that enters all structures, and depending on the quality of the materials, it can cause the construction materials to break, crack, or even fail completely. Wood and steel structures can generally withstand shaking, but brick, stone, or adobe are more prone to failure.
Okay, we'll be continuing, my friends.
Hello everyone, my name is Tunjung Sari Dharma Prastiwi, and right now I will explain about earthquake-resistant building principles. The basic principles contain 4 points. The first one is the basic principles of structural rigidity of the house. This principle can make the structure more solid against shocks. Rigid structures such as reinforced concrete, if made properly, can absorb earthquake vibration well. The stiffness of the structure can prevent the possibility of the building collapsing when an earthquake occurs. There is an example of wrong structure and right structure. As you can see in the wrong structure, the reinforcement is not linked properly. When the structure is right, the reinforcement will be intertwined. Second is the principle of flexibility. It is possible that the structure of the building can move on a small scale. For example, by using the principle of roll connections on load supports. What is meant by roll support is a type of loading relationship that can move on a small scale to damp vibration. Third is the principle of using light and chewy materials. The principle of using light and chewy materials, namely using lightweight materials that are not more dangerous if they collapse, and lighter so that they do not overload the existing structures. For example, wooden structure can accept shifting relationship between wood on a moderate earthquake scale. And the last one is the principle of fragmentary masses. The principle of segregated mass, which is to break the building into several smaller structures so that the structure is not too big and too long, because if it is hit by an earthquake, it must damn greater vibration. I think that is all for me. For the next materials will be given by my friends Ila Maharani.
Next, we will talk about community preparedness to face earthquake. First, we will talk about the definition. Preparedness is action from governments, communities, or individuals to respond to an earthquake anywhere and anytime without knowing the signs of the earthquake before it happens to reduce the impact of an earthquake. Next, about community preparedness. First, persuade the community to participate to building an earthquake-resistant house. This is very effective to providing community preparedness after several years of earthquakes. Next, monitoring and spreading the information on potential natural disaster, improving skills and quality of natural disaster management, and socializing about natural disaster management, etc. And the last, for conclusion, the community, especially in this journal we used, already has preparedness to facing earthquakes for covering the fields of infrastructure, buildings, economy, etc. But in the future, the government and the community have to support each other to preparing for an earthquake preparedness to create an earthquake resilient community. By the way, we get this information for Journal of Community Service 2020 from Earthquakes in Bantul 2006.